Namaskar. So today in school we are celebrating Diwali. So the corner has been decorated by the beautiful lights, balloons, rangoli, etc. So why not chemistry also? So now what we have planned, we have also decorated our lab by very beautiful this wall hanging, and this wall hanging is just like a chemistry educational hanging. We can also say, we can say it's art integration learning, and the topic is nothing but what? D block. Okay students, so this is a D block, and the D block is nothing but the full of the reasoning, and we have discussed all the properties, and that properties has been displayed in the form of wall hanging. You can see D block properties, what are the properties and what is the reason for that. As for example, small size ion. Why D block element has the small size ion? What is the reason? Because of high effective nuclear charge. So these are the various properties. Second, high ionization temperature. Reason, small size, high nuclear charge. Third, why D block elements show variable oxidation state. And the reason is involvement of Ns and N-1 d electrons, means more number of unpaired electron in d orbitals, and participation of both Ns, N-1 d electrons. So this is the reason there is the formation of variable oxidation state, and even variable oxidation state has been displayed in the form of again wall hanging, that I will show in the other part also, right? And the second is the high melting point. Next property, why transition metals have high melting point? What is the reason? Immediately you can display, you can see this wall hanging which has been displayed in the chemistry lab. Come, revise anytime. You are free to revise all the reasoning questions and reason which come in the board exam, and it is very, very important concept. So what I was talking? What was the next property? Yes, bache?
Transition elements.
Why transition metal have high melting point? Unpaired electron, more number of unpaired electron, strong metallic bond. You can see here, every question and their answer has been written. Transition elements, why D block elements called transition elements? It should be on top, but it is kept in middle. Why D block elements called transition elements? Because of partially or incomplete filled d orbital, or we can say penalty method. So just see the question and answer. So it's a very good revision tools also. Why the next property, why they have tendency to form interstitial compound. What is the reason, bache? What I discussed in the class? Small size. Small element can trap into their interstitial site. So you can revise from here. Why transition elements are paramagnetic in nature?
Ma'am, because of unpaired electrons.
Very good. Unpaired d electron, unpaired electron in d orbitals. Very nice, very good. Why they form the colored ions? Because why they form the colored ions? Tell me the answer, bache.
Ma'am, unpaired electrons.
Unpaired electron, and hence they show DD transition, which we have discussed. But in exam, simply you can write any transition metals form in the unpaired electron, DD transition. Why they form catalytic? Why transition metals are good catalyst? Sorry, catalytic property? Because why?
Ma'am, because of multiple oxidation states.
Yeah, because they have the multiple oxidation state, large surface area. Why transition metals form complexes? Because of small size. High charge upon radius ratio means high charge, and the availability of vacant d orbitals. Why they have tendency to form alloys?
Ma'am, because of similar atomic size.
Very nice, you have done, and you see also, and you can reply also. So they have tendency to form the alloy because similar atomic radii. And why they can form? Okay, and the last concept, lanthanoid contraction. What is lanthanoid contraction?
Ma'am, because of the poor shielding effect of F block.
F orbitals. It's by this
F.
It should
F
be
orbitals.
a poor shielding effect of F orbitals. So there is a high effective nuclear charge, and hence. So I hope you are happy.
Yes,
so
ma'am.
Happy Diwali with your concept of D block element and wall hanging. So far we have done this D block properties as an art integration form, as a Diwali celebration, as a Diwali decorative items. Let's move and see the variable oxidation state of D block element. All of you come and let's check. Now, so this is the oxidation state of transition elements, and we are discussing only one series, that is 3D series. Okay, let's see how the oxidation states are varying of all elements of the particular series. That is 3D series. All of you know scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is 3D series element. And what is the configuration of scandium? Let's see. What is written? Argon 18, 3D1, 4s2. So what is the outermost configuration? That is 3D1 and 4s2. So what is the total valence electron? 3. So how many electron can we lose from here? 3. So we see how many variable oxidation state possible of each element. So now you can see it's very nicely presented in the form of this wall hanging at the door, and you remember this one also, and this one is, now you see what is oxidation state of scandium?
+3.
+3, +2,
+3.
titanium +2, +3, +4. So like this you can see.
Ma'am, why is +4 encircled in titanium?
Okay, very good question. Okay, this +4 has been circled. So you can see in all cases the oxidation state has been circled. Here 3, here 4, here 5, here 6, even here 3 also. In the other 7, here 2 also. In case of iron, 2 and 3. In case of cobalt, 3. In case of nickel, +2. Copper +2, and zinc only one oxidation state, right? So why these has been circled? And very good question, because of these has been circled as a stable oxidation state. And you know the oxidation state stability depends on what?
Ma'am, the valence electrons.
Yeah, configuration. We can say configuration. So the last one, with anyone with the circle, that is a stable configuration, and especially the last one, that is +4. Because after loss of 4 electrons, what configuration is left? Argon. That is a noble gas configuration, right? So this is the reason. So these circles are stable oxidation state, and the oxidation state are stable due to stable configuration, either in terms of noble gas configuration or half-filled. As you can see, these are the stable configuration: +4, +5, +6, +7. Due to noble gas configuration, but in between you can see chromium. What is the stable state?
Ma'am, +3.
+3 also stable state. Why +3 stable state? Already I told in the discuss in the class. Okay, again repeating. What is the outermost configuration?
3d5, 4s1.
Yeah. So how many electron can we lose over here?
6.
Okay, +3 means there is a loss of 3 electrons. First from S and then from D. So S 1 electron has been lost, और D से 2 electron निकल गया. So what the configuration is left? 3D3, and 3D3 is a half-filled.
Half-filled T2G, ma'am.
In terms of T2G3, very good. Because you think that D5 is the half-filled, but D3 half-filled is also stable configuration and more stable than D5, because in terms of T2G3, which we have already discussed in the coordination chapter. Okay, so like this, here also you can see the Mn has +2 also stable, beside +7. Why +2 stable? Because of loss of 2 electrons. What is left? D5.
D5.
That is a half-filled. Okay. Similarly, iron has +3 because of half-filled configuration. So you can see the scandium has only one oxidation state, and after that there is a 1,1 oxidation state increases. And what is the common oxidation state in all cases?
Ma'am, +2.
+2. So +2 is the common oxidation state of 3D series. But +2 means after the loss of S2 electron. But after the loss of S electron, then the electron loses from D orbital also, 1 each. So +2, then what? +3, then +4. +4 means noble gas configuration. So you can see 4, now 2, 3, 4, 5. Then what happens? 6, Then what happens? 7.
7.
So initially you can see the oxidation state increases till manganese, and manganese is the maximum variable oxidation state.
Yes, ma'am.
So why initially first increases? Because of increase of number of unpaired electron in d orbitals. What is the configuration of scandium? D1, 1 unpaired. What is this? D2,
D2.
2 unpaired. So as the number of unpaired electron increases, the oxidation number also increases because unpaired electron participate in bonding. So Mn is the maximum number of unpaired electron. So this is the reason Mn has the maximum number of variable oxidation state. But then after start decreases. After Mn, so you can see this is just like a pyramid also you can say, or it is just like a wall hanging also. So first increases till manganese, and then start decreases. You can see. Why start decreases? Because after Mn means from iron the electrons start pairing, because iron configuration is what? 3d6. 3d6 means now
Pairing
5
starts.
unpaired and in case of Mn there is a 5 unpaired, but in case of iron 4 unpaired and 1 paired.
Paired.
So from D6 the pairing of electrons start and the paired electron not participate in the bonding. So this is the reason the oxidation of the star decreases. And why zinc is only 1 plus 2? Because there is a loss of only S2 electron.
4s.
Because D is now fully filled. Okay. Now there is a two questions arises. Why scandium does not show plus 2 oxidation state, right?
Yes.
I told the common oxidation state is plus 2 because of loss of 4s2 electron, right? So scandium has also tendency to show the plus 2 state, but plus 2 is not what? Stable. Why plus 2 does not show? I already discussed in the previous class even also. Anybody can reply? Shall I repeat once? Okay. So why plus 2 is not stable? Because after loss of S2 electron, how many electron left in d orbital? 1. D1. And 1 electron easily can be lost by less amount of energy to attain the noble gas configuration. Right? So this is the reason the plus 2 easily oxidizes into plus 3 and attain the argon as a noble gas configuration, or we can say D1 is not very stable and can and has tendency to lose that electron, right? Okay, now 2-3 more questions. If I ask, name the transition element which does not show variable oxidation state.
Ma'am, zinc and scandium.
No, not zinc, only scandium. I ask question, name transition element.
Yes,
And zinc
ma'am.
is not a transition element because already we have discussed zinc is not a transition element because its d orbital is completely filled, right? So scandium, name one transition element. That answer will be scandium because scandium is transition element. Okay, but if I ask, name one d block element which does not show variable oxidation state, in that case what you can say, either scandium or zinc. D block, because both are D block element. In case of D block, you can write any one of the answer, scandium or zinc. But when the question will ask, name the transition element, then answer is only scandium. And why scandium does not show variable oxidation state, only one oxidation state, already I have discussed. Second question asks, why manganese is more number of variable oxidation state, just I have discussed, because more number of
Maximum unpaired
unpaired
electron.
electronic. And one more question is very, very important. Copper 1 plus, copper 2 plus. Copper 1 plus. What is the configuration of copper? 3d10, 4s1. Plus 1 means loss of 1 electron. S1 से एक electron निकल गया. So what is left? D10.
3d10.
And D10 is a highly stable configuration. So plus 1 should be very, very stable oxidation state. But plus 2 is also more stable in aqueous state. So in copper, plus 1 where the D10 configuration is still 2 plus is more stable in aqueous state because of high hydration enthalpy. Because, and why high hydration enthalpy? Because copper 2 plus has a smaller size. And due to high hydration enthalpy, copper 2 plus is more stable. 3 plus stable, already I told. was T2, T3 after configuration. So this concept, the variable oxidation state of transition metals, it can be easily understood by this Diwali decorative item. And this decorative item you have prepared, all of you have prepared, all of you made it. So I hope it is clear to all of you. So let's enjoy Diwali celebration and let's happy Diwali to all of you. Thank you so much.